Welcome to Python Basics with EJD. In this video, we'll be looking at Python variable data structures. In the last set of videos, where we did a lot of expansion on Python variable data types. And from what I've been saying, the variable data structures are really going to explain to us how we can aggregate data types to have data structures. And as you know, we have been using Google Colab. So to go there, all you need is a Gmail account, and then you can just type. If I want to just start typing Colab, you can already have this collab.research.google.com. And if you don't have that, you need to bring up the page, and then you can just go straight to that. So this is the 11th video, and it is about Python variable data structures. Python variable data structures. We got ourselves introduced to that already in one of the previous videos where we looked at data types and data structures. We saw data types as including integers, floating point numbers, complex numbers, booleans, and strings. And I've made a series of videos to talk about different operations in all of these areas, like arithmetic operations for real numbers, then complex number operations. Then we looked at Boolean operations and string operations too. All right, so let's look at Python variable data structures in some depth. First of all, Python variable data structures allow storing multiple values together. So you have your data type. So if you store more than one, say if you maybe you have integers. Now, if you store multiple integers as one under one variable name, that's why both of them are Python variable something, Python variable data type, Python variable data structures. So if you store more than one integer, or it may be a mixture of all of these types of data types, then you have a data structure. So data structures allow storing multiple values together. Python variable data types like integers, floating point numbers, complex numbers, booleans, and strings are the building blocks for Python variable data structures. So it is the aggregation of this that lead you to Python data structures. And Python data structures include lists, tuples, sets, and dictionaries. Lists, tuples, sets, and dictionaries. So let's go one after the other looking at these things. First of all, let's look at what a list is about. So by definition, a list is ordered. It is an ordered mutable collection of data. Now, when you talk about a data structure being ordered, it means that you can index its elements, meaning that I can say I'm interested in the first element or the fifth element or the seventh element and things like that. That is the idea of it being ordered. On the other hand, when you say a data structure is mutable, it means you can add to it, you can remove from it, you can change, you can switch one of its items like that. So a list is ordered. That means you can index its elements, and it is also mutable. You can add to it or remove from it and do all that changes to it. So in general terms, the syntax is such that you have square brackets like this. So lists are declared using square brackets in short. So they are declared using square brackets where you have item 1, item 2, item 3, whatever the items might be. They can be strings, they can be numbers and things like that. So a very good example of this is what you have here. Imagine we have a list of fruits. So, and because apple, banana, and cherry are strings, you have to put them in quotation marks. If not, you can have some error. Okay. So you have fruits, apple, banana, cherry, and then you just print fruits, and then it prints apple, banana, cherry for you in that order because it is ordered. Order really matters. When we get to see unordered data structures, you'll discover that the way you have it listed, by the time you print it, the order may not be like that. So that's one way. So because lists are mutable, it means we can actually add to it. So for instance, we already have apple, banana, and cherry here. If you want to add orange to the list, for instance, which wasn't there before, you can just say the fruit, this is the variable name now, fruits. So if you have fruit.append, append is the keyword that you use here to add something to your list. So you say fruit.append orange, that means add orange to the list of fruits. And then by the time you print the new fruits, now you have apple, banana, cherry, orange. So append adds whatever you want to add to the end of what you have, because order is very important in this case. So now we have added orange to this. Then what if, because it is ordered, right? You can actually index the elements. And don't forget, the Python in Python, indexing starts from 0. So if you have apple, banana, cherry, now it means apple is 0, banana is 1, cherry is 2. But then now we have updated it. We have apple, banana, cherry, orange. So that apple is 0, banana is 1, cherry is 2, orange is 3. So if, and by the way, because we have added orange to it now, this new list of fruits will override the previous one because we are using the same variable name. So if you want to index a fruit, you want to index fruit 0, that means you need this first element because first in Python is 0. So because you want to index the first element here, oh, okay. No. This is different. You want to modify the item rather. So if you say fruit 0 is grape, what you are doing here is that you are modifying the list and you are replacing apple was in 0 place before. So you want to push apple away from that 0 place and put grape there. This is what this one means. Sorry, indexing is different. We are going to see that in the next cell. So if you say fruits 0, with this square bracket 0 equals grape, meaning that you want the first element in that list to now be grape. So instead of having apple first, you now have grape, apple, banana, cherry, orange. So if you print this now, see what you have. You now have grape, banana, cherry, orange. Okay. Yeah. Okay, so it is replacing apple actually. So it's not pushing it away, it's replacing it. So apple is gone and we have grape replacing it. That is what we have done in this situation. Okay, so you can replace, so that is mutability. So because you can replace an element of a list with another element. That's another level of mutability. Mutability means you can add to it, you can subtract, you can add an element, you can remove an element, and you can replace an element. That's mutability. Then here, just like I said, because it's ordered, you can actually index the elements. So for instance, imagine you have you have fruit 1. So in this case, now since we are printing, fruit 1 means that if you see the difference between this one now, you have fruit 1 and you have fruit 0 equals grape, right? Fruit 0 equals grape means replace whatever is at position 0 with grape. But fruit 1 here means whatever fruit 1 is, I want you to print it. So it means fruit 1 here, grape is 0, banana is 1, cherry is 2, orange is 3. So fruit 1 is going to be grape, right? So when we so fruit 1 will be banana because grape is 0, banana is 1. Then fruit minus 1 means start counting from the back. So fruit minus 1 is going to be orange. So if I run this, I'm going to have banana and orange. So because fruit 1 is banana, I use this print. This print is what is creating this space because if I comment this out now, the gap will not be there anymore. So, but let me remove it just to create that space. So fruit minus 1 means you're counting from the back. So this -1, -2, -3, -4. So if I say fruit -4, okay, let me just go, let me copy this and paste it and change that -1 to -4. So fruit -4 will now be grape because -1, -2, -3, -4. We count from the back like that. Okay, that's about list. Now, this is just a general introduction to Python variable data structures. So in the next set of videos, I'm going to take them one after the other and explain in more depth. So use cases for list will be when you want to store ordered data that needs to be changed frequently. All right, maybe you have a register you need to update from time to time or whatever. So tuple, when we come to tuple, a tuple is just like a set, right? The only thing is that there's a difference. It is immutable. A tuple is ordered like a set, but unlike a set, it is immutable, meaning that you cannot add to a set, you cannot remove, you cannot add to a tuple, you cannot remove from a tuple, you cannot replace an item. And if you compare now, by definition, a tuple is an ordered immutable collection of data, and the syntax is you have parentheses, normal brackets, as you may say. So up here, to declare a list, you need square brackets, but to declare a tuple, you need a parenthesis like this. All right. So two differences now. A tuple is immutable while a list is mutable. Then, for coming about how do you declare a tuple, you need parentheses to declare a tuple, or you need square bracket to declare a list. So those are the differences. But apart from that, every other thing remains the same. So, and because a tuple is ordered, right? We already know it is immutable, so you can't add or remove from it. So because of that, but then it is ordered, so that means at least you can index it. So see what happens here. So if we declare a tuple to be coordinates coordinates don't change, right? If you are talking about a particular location and the coordinate is 10.5 by 20.3, and that doesn't change. So we can just print that out and we have this result like this. And then because we cannot add to it or remove from it, but at least we can reference the item. So, and in this case now we have just two items. And by Python, going by Python, the first one is 0, the second one is 1. So if I print coordinates 0, it will give me 10.5. If I print coordinates 1, it will give me 20.3. So if I run this now, that's what it gives me, 10.3, 20.3. What are the use cases for tuples? There are cases where you are working with data that don't change, right? And they are ordered. So use cases maybe for something like fixed data that shouldn't change, e.g. geographic coordinates, which do not change. And so we've talked about lists, we talk about tuples, which look so much alike, except for the fact that tuples are immutable, while lists are mutable, and then the manner of declaration is different. For list, we have square brackets. For tuple, we have parentheses, which I like to call common brackets. Then I go on to set, which is another data structure in Python. Of course, if you have done some mathematics, I think even at high school level, you'd have done some mathematics, and there you talk about set theory. In this, of course, a set is an unordered, mutable collection of unique elements. So now this is the first data structure that is unordered. So in this case now, because a set is unordered, you cannot reference its items based on the position it occupies, because you can declare a set a particular way and it brings out a different kind of result, right? So a set is an unordered, mutable collection of unique elements. That's another very important part. Okay, mutable because you can add to it, you can subtract from it, but then you have a collection of unique elements. So if you have a repetition of a particular element, it will not be recognized when you declare it as a set. So if you don't want duplication, then set is what you need. Then the syntax is you use curly braces here, or you use braces or curly brackets, yes. So the items still go like that. But then once they are declared in curly braces, you know that you are dealing with a set like that. And the items are unique. Okay, so now set is unordered, but it is mutable and it has to contain unique elements. So imagine this, that you have unique numbers 1, 2, 3, 3, 3. So you have a set called unique, the variable name is unique numbers, and you have 1, 2, 3, 3. So it will recognize 1, it will recognize 2, but then 3 is repeated. So it will not account for this. Any other duplication you have will not be taken care of. So duplicate 3 will be removed automatically, because a set doesn't take duplicates. So if you run this now, 1, 2, 3, 3 becomes 1, 2, 3, because it has to be unique collection of elements, right? So because a set is mutable, you can add to it. So by the way, this is just an introduction to Python variable data structures. So we are going to talk about set operations in a separate video. So imagine that this same variable, unique numbers, and if you want to add something to it, you just have to add 4. So it means you want to add 4 to the set now. So that means you're not going to have 1, 2, 3, 4. By the time you print this, as you can see, we have 1, 2, 3, 4. So what are the use cases? It is good for removing duplicates and mathematical set operations like union, intersection, difference, and so on and so forth. Right? So here we talk about dictionary. The next data structure is dictionary. Now, if you look at the syntax for a dictionary, it is also curly brackets or braces, like in the case of set, but a dictionary is unordered. Don't forget, a set is also unordered. So dictionary and set are both unordered, while list and tuple are ordered. But then a dictionary is mutable. A dictionary is mutable, just like a set is also mutable. So the only immutable thing is tuple, right? So only when we talk about immutability, only a set, only a tuple is immutable. But when we talk about order, list and tuple are ordered, dictionary and set are unordered. So a dictionary is an unordered, mutable collection of key value pairs. So another uniqueness of dictionary, just like the idea of a normal dictionary for languages, right? Maybe you have a word entry and the definition of that word and the usage and things like that. So you have a word. The word now is the key, and the value is like the definition and how it is used. So in Python, a dictionary is it is unordered, mutable collection of key value pairs. Because it is unordered, you cannot reference the position, but basically it is a key value pair. So you can actually you may call a particular value by calling its key or something like that. So imagine the syntax: curly brackets, then you have the key, and then you have the values. Key 1, value 1, key 2, value 2, and you can go on like that. In fact, dictionaries are particularly useful if you are into data analysis. Maybe if you see my playlist on data analysis with Python, I think you will see that one way to declare your data set is to use a dictionary. All right. So like say you have name and you list all the names, you have their age, you list all the ages and things like that. So a dictionary is an ordered mutable collection of key value pairs, and we have the syntax right there. Okay, imagine we have a dictionary called student, and then of course in that case you need to use the braces, and then you have the key is name, then the value of that name is John. The another key is age, and the value is 21. So if you print this now, you're just going to have that name John, age 21. Then you can actually add a new key value pair to that, right? So what you just need to do is you call the variable student, and then in square brackets, then you want to create a new key, which is grade, and then the grade for the so you want to add John's grade, then you say grade is equal to A. So in that case, by the time you print the new variable student, you're going to have name John, age 21, and the grade is A. So you can do that. Of course, we're going to have a more comprehensive look at this in a subsequent video. Okay, so now because although a dictionary is unordered, but so because it is unordered, you cannot index it using its position, but you can actually use the key of a particular key in a dictionary to reference the actual value. So in this case now, if you're using the key age, if you want to know John's age or the student's age, just say print student age. So using this age now, it will automatically extract the value of that age for you. So if you run this, you get 21. That's the age we have right there. And the use case for dictionary will be for fast lookups and structured data mapping. So like I said, it is one way to declare data sets in data analysis, for instance, when you use Python. So dictionaries are really good for declaring data sets in Python for data analysis. But another thing, when you have a list, a tuple, all those, you can actually you can use them, as you can convert a list or a tuple, for instance, into a Python data frame for data analysis. So if you look at data analysis, you see all of that right there. Okay, so going forward, we can talk about nested data structures. In fact, this is the kind of thing you have when you are dealing with data sets, right? In data analysis. So nested data structures, you can actually have some kind of nesting, putting together. So you can, for instance, you can combine structures. You have a list, because it's a list here because you have a square bracket starting it. So that's clearly a list. But inside that list, you now use dictionary to populate the list. So you have name Alice, the scores, maybe in 3 subjects, 85, 90, and 88. And we have another name Bob, the scores 78, 81, and 86. Then if you print the students now, then you have all of that like that. Okay, so you have name Alice and the scores 85, 90, 88, and all that. So you can have nested, you can combine structures like that. In this case now we have combined list and dictionary. So inside the list you have a dictionary, and inside the dictionary you have another list like that. So you are combining the structures at multiple levels. This is particularly useful for complex data sets like JSON responses. JSON is one of those very not so heavy data sets you can use in data analysis, especially when you're working with when you're using Python for machine learning, or maybe some other program. So this kind of nested data structures can actually be useful for complex data sets like JSON responses. So how do you know the kind of data structure to use in each situation? So, for instance, when do you use list? Number one, a list is ordered. So if you're dealing with something, if you want to be able to reference the elements using the position it occupies, so you can use list in that case. Of course, you can also use tuple. The only thing is that you cannot. Okay, well, we'll talk about that later. For set is not ordered. Dictionary is actually ordered in the sense that dictionaries preserve insertion order starting from Python 3.7. So starting from Python 3.7 plus, so normally dictionary is supposed to be unordered, but starting from this release of Python 3.7 plus, then a dictionary now becomes like an ordered data structure. Then talking about mutability, only tuple is immutable. So if you need to change values, you cannot afford to use tuple. But if the values don't change, then you can use tuple. So for the others, they are mutable. You can add to them, remove from them, and things like that. So if you have a class register and a student can come at any time, or a student can leave the class and things like that, definitely you don't want to use a tuple. You can use a list, set, or dictionary. Now, which of these ones allow for duplicates? Only list and tuples allow for duplicates, but sets do not. Then for dictionary, you can only have unique keys. Though the values may be different, but the keys have to be unique. So though it is not, it does not allow duplicates in the sense that the keys cannot be duplicated, but the values can be duplicated as far as the keys are unique. All right. Then talking about indexing method, you can index a list by using integers. Like, so it is O-based. O-based meaning that the first position in a list and a tuple they are zero-based rather. So the first any element in the first position are occupying position 0, right? Then for set, not applicable, right? You cannot index the elements of a set, so not applicable. For dictionary, you can use the key just like we did before when we extracted the age. Then common uses for lists are good for sequences of items that are subject to dynamic changes. Tuples are good for fixed collections and constant data. That's data that doesn't change. Then set is good for unique items and set operations, while a dictionary is good for key value mappings. And example syntax, you have all of that. How do you declare a list? So my list, you have square brackets 1, 2, 3, for instance. My tuple, you have parentheses 1, 2, 3 as the element. Then my set, you have braces 1, 2, 3. But for my dictionary, my dict, you have key and value, basically. All right. So some advanced Python data structures. So there's a module called the collections module. So in that module, you can use the named tuple. That is tuples with named fields. And you have DQ, which is double-ended queue. You have default dictionary with default values. You can have counting hashable objects. Therefore, you can also have the array module. From the array module, you can have more memory efficient numeric arrays. And then you have heap queue module, which is good for priority queues. So if you want to dig deeper into the idea of into some more advanced data structures, you can look at these modules in Python, right? In summary, Python provides both simple and complex data structures to organize and manipulate data efficiently. So the simple type may just be the data types where you talk about integers, floating point numbers, complex numbers, booleans, and strings. So the choice of structure, any structure you want, will depend on the type of data you are working with, the operations you need to perform, and the performance considerations themselves. And with this, we come to the very end of this video on Python variable data structures, including lists, tuples, sets, and dictionaries. Let me know how helpful this video is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have not subscribed already, you're missing a lot. So go ahead, subscribe, and hit the notification bell so you can always get alerted each time a new video is released. If you have subscribed already, thank you very much. Don't forget to like, share, and comment so that more people can have access to this great content I have going on here. And of course, you can become a member of my channel by clicking on join and seeing 3 different levels of membership. And each of the levels comes with a special privilege for you. So check them out and see how that works for you. Till I come your way again, keep doing Python right. Bye.